So we'll call this section 15.5, and this is all about two-way frequency tables and what probabilities we can calculate with two-way frequency tables. So we've worked with frequency tables already. The frequency tables we worked with before just had one piece of information about multiple categories. We had a frequency table on our quiz. A two-way frequency table has information about two categories, or two or more categories. So here we have information about the number of people that exercised, the number of people that didn't exercise, and the number of people that caught colds, and the number of people that didn't catch colds. So we have information about exercising, and we have information about colds. So we call this a two-way frequency table. Or a contingency table. And like frequency tables, the frequency tables that we already talked about, we can use a two-way frequency table to calculate experimental probability. But the two-way frequency tables give us a little bit more information that we can work with. So let's look at one way that we're going to use two-way frequency tables. So the first thing we're going to do, what I'm going to do is just do several examples from this one two-way frequency table so we can see how to use it. So for our first example, we want to know that the probability that if someone caught a cold, so we did a survey of people and asked them about their exercise and whether or not they have a cold. So we want to know the probability that someone caught a cold and did not exercise. So what we do when we want to figure out a probability, this is just like our other frequency table. We're going to look at our favorable category and we're going to figure out our total category. So when we have, in this particular example, it just wants to know the probability that someone caught cold and did not exercise. So what I'm going to do is say that the favorable is the number of people that caught cold and didn't exercise. That's our favorable, that's what's going to go on the top of our probability calculation. So what we're doing here is calculating the relative frequency of someone catching cold and not exercising. So we're calculating relative frequency. I just want to remind us what we mean. Relative frequency is the same as finding the probability. And our relative frequency is the frequency of the category, our probability, equals the frequency of category divided by the total. So our category, the category that we're interested in is caught cold and did not exercise. So let's look at our table. So I'm here in the caught cold column, and I'm going to look at the did not exercise row. So we have 10 people that caught cold and did not exercise. That's what the table tells us. We're looking at this entry. 10 people caught cold and did not exercise. And how many total people did we survey? We surveyed a total of 50 people. So if we add up our totals in this row, it comes to 50, and total in this column comes to 50. So we counted 50 people. So 10 people out of all 50 caught cold and no exercise. We had a 50 total people. So our probability is just 10 over 50, which I can reduce to 1 in 5, or I can write that as 20%. So based on our survey, based on our table, 20% of the people caught cold and did not exercise. So that's all we do to find relative frequencies. We look at the category we're interested in, find that number, divide by the total number in the entire table. So we took 10, because 10 caught cold and did not exercise, and we had a total of 50 people. So that's one way we can use a two-way frequency table. Questions on how we did that calculation? All right, another way that we can use a two-way frequency table is for what we call conditional probability. And we talked about conditional probability a little bit the other day when we said that we were calculating the probability of dependent events, where the probability of the second one we had to find after the first one happened, because when the first one happens, it changes what happens with the second one. That's an example of conditional probability. The second probability changes because it's dependent on the first one. We can use two-way frequency tables to find conditional probability. So let me write just a little reminder of what conditional probability is. So conditional probability is the probability of an event given or after another event has occurred. So conditional probability is a probability of an event given that another event happens, or after another event happens. So we talked about the after another event happens the other day when we talked about dependent events. We can calculate conditional probability with our two-way frequency table also. What we said before, what we wrote was probability of A then B. We also wrote the probability of, we could also write B after A, or the probability of B given A. Our shorthand for this is we write the probability of B given A. So this straight up and down line means we're calculating the probability given that A happens, or after A has happened. That's how we write conditional probability. Probability of B given A. So all of these things mean the same thing. A then B, B after A, B given A, or the symbol probability of B given A. So we can use our two-way frequency tables to calculate conditional probability. So let's look at an example of that. So we want the probability of no cold given no exercise. So we're saying we know the people didn't exercise. We know that they didn't exercise. We want to know that if we know they didn't exercise, what's the probability that they did not catch a cold? So what we're trying to calculate, if I write it in symbols, probability of no cold given no exercise. To use our two-way frequency table in this example to find our conditional probability, we only have to look in the given category. So we're only looking in the given category. We know that the given thing happens. We know that they did not exercise. We know that for sure. So we only have to look at that category. So let's look at, in the given category, the total in the no exercise category. So let's go back to our table. The total in the no exercise category. No exercise. How many total did not exercise? 12. The total is 12 people did not exercise. So that's going to go on the bottom of our fraction. In the given category, how many people did not catch a cold? In the no exercise category. 2. We're only looking in the no exercise category. We know that happened. So the total is 12. 2 did not catch cold. So let's go back. I'm going to go back to my page. So the total is 12. 12 people did not exercise. 2 people did not catch cold. So our probability of no cold given no exercise is 2 out of 12, or 1/6. So if we have a given category, we only look in the given category to pick out our numbers for our probability. We only look in the given category. So that's how we calculate conditional probability with a two-way frequency table. We look in the given category. And 1/6 is about 17%. So the difference in our first example said we wanted the probability that someone caught cold and did not exercise. So we're looking at both. That and gives it away. The and is what tells us we're looking for the total probability. When we have the word given or after or we know that, one of those kinds of words, that tells us that we're looking for conditional probability. Usually you'll see given or after will be your hint that you have conditional probability. Questions before we do? I want to do one more example with conditional probability. Okay, let's look at one more example. We'll do some homework, some practice with conditional probability over the long weekend, and we're also spending one more day on conditional probability, so we'll have time in class to work and ask questions so that we make sure that it makes sense before we move on. All right. My second example, we're going to calculate another conditional probability. We want to know the probability that a person exercised given that they caught cold. So, caught cold is our given category. So we're only going to look in the caught cold category. So we're only going to pick our numbers for our probabilities from the caught cold category. So I'm going to find the total. We'll go back and find the total in the caught cold category. I'm going to go back to my table. In the caught cold category, caught cold is this column. How many total people caught a cold? Total people in the caught cold category is 18. Total is 18. I'm looking in the caught cold category. And exercised, and this is in caught cold category. So let's go back to our table. In the caught cold category, how many people exercised? 8. So I'm in the caught cold category. The total is 18. 8 of them exercised. Caught cold is our given category. I'm only looking in the given category. So 8 exercised. So exercise in the caught cold category is 8. So the probability of exercise given caught cold is 8 over 18. And I can reduce that to 4 over 9, or about 44%. So about 44% of the people exercised given that they caught cold. So of all the people that caught cold, 44% of them exercised. So when you have a given category, you only look in the given category to find your numbers to figure out your probability. And that's how we figure out conditional probability. Questions? All right. Let me pass back your folders.